school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant grace, in God we trust.
You are welcome once again to AGPS TV. Today marks yet another important day in our academic lives. In the previous lessons, I have dealt with set of numbers. I have dealt with types of sets. And then the last time I was able to deal with you in respect to how to be able to list a number of subsets when you are given a set. Today I want to crown the set problems. I have initially told you that there are 6 or 7 topics that are very relevant if you want to do well in your final exams. And so one of them was set. I have talked about statistics. I have talked about geometric construction. I have talked about rigid motion. I have talked about linear graph or line graph. I have talked about polygons. And then I've talked about twin topics. That is linear inequalities and the linear equations. And so, having said all these things, I have decided to take you through set. Today, I want to conclude and deal with how to deal with 2 set problems. It is a topic that has become very challenging to most students. And today, I want to use this opportunity to remove that barrier or that challenge from there. Now, so our topic for today is going to be 2 set problems. Now, for 2 set problems, please, if you can reduce my light for me, the light. 2 set problems. Now, for 2 set problems, if you have 2 sets, say set A and set B. If I have set A and then if I have set B, and then these 2 sets A and B are such that they have an intersection set, or they have members that belongs to set A and set B, then arises a set problem. Then arises a set problem. If you have 2 intersection sets, then we have a set problem. So if you draw a Venn diagram, and then we have 2 intersection sets. Set A and set B. It rises 4 regions. If you have 2 set problems, it brings about 4 regions. So we have region 1. So I'm going to denote it with R1. Then region 2. Then we have region 3. And finally, we have region 4. So if we have two intersection subsets, these are going to be the four regions. Now, when you say region 1, it is for those who belong to set A only. Set A only for R1. Now, when we talk about region 2, denoted with R2, we are going to have set A and set B, or you can simply call A intersection B. The last time I taken you through intersection. So we have A intersection B for region 2. Then again, I have region 3. And then region 3 is going to be for set B only. Set B only. Region 3 is going to be for set B only. And then finally, we have region 4, denoted with R4. Denoted with R4. So region 4 is going to be a complement of A union B. Region 4 is going to be a complement of A union B. And in my previous tutorials, I took about 10 minutes to deal with complement of a set. So we are going to have A union B all complement. In other words, members that are in the universal set but not in set A and set B put together, and so they are going to be in region 4. Now, I have said R1 is for set A only, but let us take set A. If you take set A, you realize that it comprises of region 1 and 2, the whole of this where I am indicating. So where I have indicated is set A. And so you see that when you talk about set A, it involves region 1 and region 2. So if you want region 1 only, then region 1 only is going to be set A, which is R1 minus R2. So set A only, set A only set A only is equal to R1 minus R2. So similarly, our set B only is going to be region 3 minus region 2, where region 2 or R2 is going to be the intersection set. Now, this is the preamble that you must understand. So, we are also going to deal with how you'll be able to solve for if you're asked to deal with two set problems. Don't forget that we are going to have our universal set U. The last time I said that the universal set is all the sets under consideration, and that if you put all the sets together, it's going to give you a universal set. And because this has four regions, then quickly, our universal set is going to be U. And then it's going to give you region 1 plus region 2 plus region 3 plus region 4. And let's name this as equation 1. So for you to get a universal set for a Venn diagram, you are going to have the universal set to be region 1 plus region 2 plus region 3 plus region 4. But if your region 4 is empty or null, if it is empty or null, in other words, there's no member in the universal set that does not belong to set A or set B, then the universal set becomes region 1 plus region 2 plus region 3. This time around, there's no region 4 because region 4 is empty. And so you can also call this as equation 2. So we have these two types of equation. Now, you can do this R1 plus R2 plus R3 plus R4. Or if the 4 is a null set, you have R1 plus R2 plus R3. You can also use a formula. And the formula is the same thing. So we have our universal set that is going to be A union B. It's going to give you number of set A plus number of set B plus number of A union B or complement minus number of A intersection B. That is if you have region 1 to 4. So this is the same as the first one. Region 1 plus region 2 plus region 3 plus region 4 is the same as A union B, which is for the union. And the number of A is region 1, number of B is region 2, and the number of A union B is your region 4, minus your number of A intersection B, which is going to be your region 2. And so we have number of A, region 1, number of B, region 3, number of A union B, region 4, and minus number of A intersection B, which is region 2. Similarly, if you come to the second part, where region 4 is a null set, then we are going to have our A union B to be number of A plus our number of B minus our number of A intersection B. So we have our A union B, number of A plus number of B minus number of A intersection B. So you can either use this or that, or you can use this or that. In both cases, you'll be able to solve your two-set problem. Now, I am coming to the part of today. All these things are my preamble. And so I am going to deal with 4 different ways to approach 4 different set problems. I'm going to deal with 4 different ways to deal with 4 different problems. And the first one I'm going to deal with, is a set problem where you are asked to find the intersection. But before I deal with the question on the screen, may I remind you, take note of this. Anytime you are asked to deal with a set problem, there are 2 conditions that you must always look for. But before you can fulfill these 2 conditions, make sure that you have read through the entire questions, please. Read through the entire questions if you want to do well in set problems. Do not read a statement by statement and begin to do it. Read and see that you understand the full demands of the question before you attempt it. And so when you are reading, the first thing is that is the set only. For example, set A only or set B only. If they do not make that statement, it means that the intersection is included. And so you must always subtract the intersection. You will always have to subtract the intersection except when they have told you that it is only. Take note, because I'll be referring you to it. When the question did not say only, we are always going to subtract the intersections from it, irrespective of the type of questions that will be given to you under two sets. But when the statement has said a set is only, it means that intersection has already been subtracted from it, and so you no longer go and do it. Let's take the first example. Now, first example. In a class of 35 students, 20 offer physics, 18 offer chemistry, and 2 offer neither physics nor chemistry. I illustrate the information on the Venn diagram. I. How many students offer all the 2 subjects? I. How many students offer physics? And then IV. How many students offer only 1 subject? I'm reading the question again. In a class of 35 students, 20 offer physics, 18 offer chemistry, and 2 offer neither physics nor chemistry. But for the purposes of my illustrations, I'll be dealing with only the I and then the II. As we move on, we'll be dealing with the III and then IV. So look at this question. It said 20 offer physics. Note, it's not physics only. It is not physics only. It is physics. And 18 offer chemistry. It is not chemistry only. And 2 offer neither physics nor chemistry. So let us consider our number of you, as the universal said, to be 35. Then our number of phases, which is P, from the question is 20. And then we have our number of chemistry. Our number of chemistry is 18. Then it says that 2 offer neither physics nor chemistry. So that is going to be your region 4. They offer neither chemistry nor physics. So that is going to be your number of P union C or complement. Then we are asked to find how many students offer all the 2 subjects. And so they are asking us to find region 2. And because we don't know region 2, let's try to denote region 2 with letter X. So we have number of P intersection C, let it be equal to X. So these are the information that has been given. So we can now draw a Venn diagram and then we put our information in. Don't forget this question is question I. So you are going to indicate it as I. And then this is going to be your universal set, which is put on the right top corner of the Venn diagram. And so you have your 2 intersection sets. And then we are going to name it as set P, which is 20, and then your set C, which is 18. And so we are now going to put them together. We have 20 for set P, 18 for set C, and then those who did not study any of them were given as 2. So we put 2 here as region 4. Then we have our P intersection C as your region 2, and then you put it together. But I have said that because they did not say that physics only or chemistry only, then you must always subtract the region 2, which is the intersection from them. Always you are going to subtract it. Always, always. Except when they said only. If they do not say only, irrespective of the question, always subtract the intersection from the region 1 and then region 3. And so I am going to do that. So I subtract them from region 1 and 3. And so that is going to be for my Venn diagram. That is good. So this is I. I am done with the I. I am done with the I. And so I am going to II. For my II, I have been told to find those who study both subjects. And so I am going to find the intersection. But I've told you that if you have region 1 plus region 2 plus region 3 plus region 4, you are going to have a universal set. And so I can have my R1 plus R2 plus R3 plus R4 equals to U, just because I have my 4. I have my 4 there. So what is my R1? My R1 is my region 1. And my region 1, what is there? Is 20 minus X. Plus my region 2. And my region 2 is X. Plus my region 3. My region 3 is 18 minus S. And then I have my region 4, which is 2. So if I put my region 1, region 2, region 3, and region 4 together, it should be equal to my universal set, which is given as 50. In that question, I want to be sure if it was 50. It was 35. So it should be equal to 35. From the question, it was 35. So I put it to be equal to 35. Then I am going to solve for S. But if you look at S plus minus S plus S, minus S plus S is a number and its identity. And a number and its identity will always give you 0. A number and its identity simply means that if I have positive 5, its identity will be negative 5. And if I have positive 10, its identity will be positive 10. Negative 10. If I have positive 10, its identity will be negative 10. And negative 10 and positive 10 gives you 0. So negative S plus positive S is a number and its identity, and it will always give us 0. So this gives me 0. And then if I put 20 and 18 and 2 together, I'm going to get 40. So this gives me 40 minus S being equal to 35. Now I am going to solve for my S. So I am going to put my S here and bring my 35 there. So if I put my 40 here, this 35 becomes negative. So I have minus 35. And if I put my S here, it becomes positive because it is negative. So I have my S. If I rearrange it, I'm going to have S is equals to 40 minus 35, and my answer is 5. So this is the first way you can deal with this problem, where you equate region 1 plus region 2 plus region 3 plus region 4. But I have also taught you that you can also use a formula. And because we have region 4, it's going to be A union B, which is the universal set. It's going to be your number of A plus number of B plus number of A union B or complement, which is the region 4, minus your number of A intersection B. And this is going to be the same thing as this. And so if you want to go by this approach, then your A union B is going to be your universal set, and that is 35. Then our number of A is 20, plus your number of B is 18, plus your number of A union B is 2, minus your number of A intersection B, and from here it is X. So you can also go by this approach. And so when you have your 35, then once again 20 plus 18 plus 2 is 40 minus X. So if you decide to rearrange it, then you are going to have you are going to bring this X to this side and it becomes positive. So I have my S is equals to, then I'll maintain my 40, then I'll bring the 35 to the right, and that makes it minus 35. And that also gives me S is equals to 5. So you can either use the region 1 to region 4 approach, or you can use the formula approach, where you use your A union B is equal to number of A plus number of B plus number of A union B or complement minus number of A minus B. That is if you have region 4. So any of these two approaches, you are going to have your 4 marks, if there's a 4 marks. So this is the first type, where you are given region 4. Now, anytime you also want to see that you are having intersection, you see that anytime you put the individual there, it is going to be more than the universal set. So it tells you that you need to subtract the intersection from it. Let us go to the second question. Let's go to the second question. This question is done, so we are doing the second question. So on your screen, quickly, said in a class of 60 students, 46 passed mathematics. Take note of this. Once again, they did not say mathematics only. They say mathematics. And then 42 passed English language. Once again, it is English language and not English language only. And said every student passed at least one of the 2 subjects. Anytime you hear a statement like that, every student passed at least one of the 2 subjects. Any student took part at least one of the subjects. It tells you that there is no region 4. It tells you that there is no region 4. So we are no longer going to use the equation 1. We are going to use the equation 2. But I told you that you must always try to read the entire question before you start work. And so the I said, illustrate this information on the Venn diagram. And the I says that how many students passed in both subjects. And so we are going to do that. Let N represent the number of students who passed in both subjects. So this time around, they are giving you the letter for region 2. So you cannot select any letter S or Y. That is why I told you to read and make sure that you have read entirely. You cannot just be putting S and S there. If you have read through the entire question, then you see that they are asking you to use N. So quickly, once again, my number of U is 60. Then I have my number of M, which is mathematics. And so my number of mathematics is 42. Then my number of English language is going to be, sorry, my math is 46. My math is 46. And then my English is rather 42. Then once again, because I do not have the intersection, I'm going to have my number of M intersection E to be N. This time around, they have told me that it should be N. So my number of M intersection E is going to be N. Now I want to draw my Venn diagram for I. So my union is 60. Then I draw my two intersection set. So I have my number of M and then my number of English. And so I have my 46 and then I have my 42. Note that I am now going to put them inside my regions. And so I have my N. This time around, I have told you that when they did not say only, you must always subtract the intersections from them. When they did not say only, you must always subtract the intersections from them. And so I'm going to have my minus N and my minus N. And that ends my demand for question I. I have seen a number of students. As soon as they do I, and then they draw the Venn diagram, they begin to make solutions for N. If you do that, we are going to give you 0, because I only demand that you should do a Venn diagram. And so when you have done the Venn diagram, it means that you have satisfied question I. Don't go and solve anything. So if you want to find your N, which is the both, then you must indicate it as II before you start your solution, so that we know that what you are doing, you are satisfying the demand for II. For I, if you go on and solve it, we did not ask you to find the intersection for I. We only ask you to do the Venn diagram. And so if you want to go on and solve it, you must make sure that you put the question number there for it to be indicated. And once again, here we have two approaches. Either you use region 1, region 2, and region 3 approach, or you use the formula approach. But I've told you that any of the approaches that you are going to use, you are going to arrive at the same key. When I say key, I'm talking about answer. So because there's no region 4, your universal set U becomes region 1 plus region 2 plus region 3. So these are the approach. So our universal set is 60. So we have our 60 is equals to, my region 1 is 40 minus N. So I have 46 minus N, rather. Then my region 2 is plus N, and my region 3 is plus 42 minus N. So this is the second equation. That is the equation without region 4. And so once again, I have taught that N, negative N plus positive N is a number and its identity. And so a number and identity will always give you 0. Therefore, we have 60 being equal to, if I put 46 and then 42 together, I will arrive at I will arrive at 86. 88 rather, forgive me. 46 and 42 gives me 88. And so I have 88 minus N. So that is what I have. 48 minus N. If I want to solve for my N, I can decide to rearrange it and bring my N here so that I have positive. I want to avoid the use of negatives. So I have my N is equals to, I maintain my 88 and then I'll bring my minus 60. Then from here, I'm going to have my n is equals to, if I take this from there, I'm going to get 28. Therefore, my n is 28. So this is the first approach. If you want to use region 1 plus region 2 plus region 3 plus region 4. Or you can use the formula approach. And in the formula approach, you can have your A union B is equals to your number of A plus your number of B minus your number of A intersection B. You can also go by this formula. And so from here, our A union B, as I said, is your universal set. And so that gives you 60. And from here, your number of A, that is those who took part in mathematics. Sorry, your number of M. This time around, your A is your M. So you have your 46 plus your number of B. That is those who took part in English language is 42. Minus your number of A intersection B. And then from the Venn diagram, we've said that we should use N for it. So we put N there. So this is the same as the region 1, region 2, region 3 approach. So our 60 will be equal to 46 plus 42 again is 88 minus N. And so when you rearrange, then you are going to have your positive N is equals to 88 minus 60. And that is going to be N is equal to 28. So both ways you are going to get the same answer. If you want to use the regions approach or you want to use the formula approach. Then we are going to the second type. The second type is when they have told you that the problem is only. Only. You see that this time around, the first one, it was mathematics, it was English, it was not only. So let's go to the second type of problem, where you are given a set problem and they tell you that the set is only. So we go to the screen and we take the second type. So if we check on the screen, there's a question that says that in a class of 225, that is 255, in a school of 255 students, 80 of them study Arabic only. Check, this time around, it is only. So you realize that this is different to the first one we were doing. The first one, that word only was not there. And then you realize that the only has been written in bold. It tells you that it is giving you an information that you must place emphasis on. And then 125 study French only. So both Arabic and French are only. And each student studies at least one of the two subjects. And I said anytime you see a statement like that, it means that there's no region 4. Each student studies at least one of the two subjects. Now, understand that in the school of 225 is going to be my universal set. So my number of U is going to be 225. Then, they said that those who study Arabic only is 80. So I have my number of A is 80, and then my number of French is going to be 125. And then they said we are supposed to draw a Venn diagram to represent the information. And then we are supposed to find how many students alpha read both subjects. And so we don't know those who read both subjects. So let's denote our number of A intersection F to be X. Number of A intersection F to be X. And so these are what we have been required to do. And so we want to satisfy I. So we are going to indicate I. And so our Venn diagram on the right top corner, we are going to have our universal set, number of U, to be 225. To be 225. Then we draw our two intersection subsets. And then we have number of A, which is 80, and our number of F, which is 125. So you put our 80, our S, and then 125. Now, earlier on, I have advised you that when they say only, it means that the intersection has already been subtracted from it. So you don't go on and subtract the intersections again. Anytime they say only, and then you add the two, it is always less than the equal or the universal set. Anytime they tell you only, if you add the two subjects, it will always be less than the 225. It tells you that the intersection has already been subtracted from it. So it is not all questions that as soon as you see the question, you begin to subtract intersections. That is why I am dealing with 4 different ways to approach 4 different types of sets. We have done the first one where it is not only. And I've told you that irrespective of the demand of the question, if they did not say only, then you are allowed or we expected that you should subtract the intersections. But if the question says only, as it is in this case, you should not, I repeat, you should not subtract the intersections from them. The reason is that it has already been subtracted already. Do not do it. So once again, we can use our region 1, region 2, region 3, and the universal set approach if you so want. And so we go to II. And the II, we are going to deal with alpha. Alpha says we should find both subjects. Alpha means both subjects. And so we are going to have our region 1, which is 80. Don't forget this time, I am not subtracting it because it's only. Plus my region 2, which is X. Plus my region 3, which is 125. And so we are going to have that. And so if I want to solve that, then this is go to the universal set, which is the 225. Then I put my 80 and 125 together. And if you put 80 and 125 together, you get 205. And so we have our 205 plus S equals to 225. Note that this time around, we are maintaining the S because it's positive. And so we don't need to transpose them. And so to make our S the subject, we are going to have our S to be equal to 225 minus 205. Therefore, (225) minus 205, my S becomes 20. So I have my S to be 20. That is for those who have read both Arabic and French. You can also use the other approach. So the most important thing that you must note is that because it is only, we are not going to subtract the intersection in this case. Then finally, we go to beta. Beta, they are asking us to find French. I told you that if we were talking about French, then we are talking about the entire region. So the ones I have indicated with the short dashes are the entire region for French. And as you can see, it is both region 2 and region 3. Region 2 and region 3 is for French. And because it is S and then 25, if you want to solve your beta, it means you must always put region 2 and region 3 together. Therefore, our number of French, which is for beta, is going to be your S plus 125. S plus 125. But we have indicated, or we have been able to find our S to be 20. And so if you put it together, then our number of French is going to be 20 plus 125. Therefore, our answer gives us 145. And that is going to be the second approach, or the beta. So when you are given a question where you are supposed to find any problem, and then it is not only, you must subtract. But if it is only, you should not subtract the intersection from it. Then I'm going to the third approach. The third approach is when we are given a set, and then we are given the intersection, and we are asked to look for another number of sets. So for example, in this case, you'll be given, say, Arabic. You are given Arabic intersection French, but you are not given French. And so you are asked to find one of them. And that is going to be the different type of set question that you can find in your final exams. And so we are also going to look at how you'll be able to approach that type of question. The reason why I'm doing this, I want to emphasize that not all set questions are having the same approach. Anytime you realize that students are approaching different types of set problems with the same approach, irrespective of the demands of the question, they are approaching it the same way. But I want to use this opportunity to let you understand that we have 4 different ways that they approach sets. And so you should know which type of set you are dealing with and how you'll be able to approach them in those ways. So we look at this example. It says 25 students in a class took an examination in mathematics and science. So the number of people in a class are 25. And 17 of them passed in science. 17 passed in science. 8 passed in both mathematics and science. And 3 students did not pass in any of the subjects. So these 3 students who did not pass in any of the subjects is going to be your region 4. And we have been asked to illustrate the information on the Venn diagram. And then for I, we've been asked to find how many passed in mathematics. Don't forget that in the information they gave, they have not given us those who passed mathematics. They only gave us science. And finally, the probability of meeting a student who passed in one subject only. And so this is what I'm saying. You'll be given one subject, then the intersection, then you are asked to find for the other subject. So once again, we write our number of U to be 25. Then we have our number of X to be 17. Then we have our number of eggs. Let me put mass first because it is advisable that the first subject mentioned should be indicated first. So number of mass, then intersection signs. From the question we are given as 17. Sorry, from the question, please, can you put the question back for me? Yeah, they said that 8 passed in both mathematics and science. So our number of mass intersection science is 8. Then they said that number of mass union science or complement, it is going to be 3. That is for region 4. So this is the information you have. But because we don't have maths, please, you can take the question from the screen for me. So our number of maths, let's indicate it with X. So this time around, we were initially using the S for the intersections. But this time around, we have it. So we put it there. But because we don't have the mass, it is when we are going to put it there. And so we can find our number of signs only. Number of signs only. So if you want to find signs only, we can subtract the intersection from the signs. I told you that anytime they don't say only, you must subtract the intersection. And because this time around we know the number, we can do the calculations before we put the answer in the Venn diagram. So we are going to have our 17 minus 8. And that is going to give me 9. That is going to give me 9. So I have that. Now, I am now going to do my Venn diagram. So I have my number of U to be 25. Then I have my number of maths. I've indicated it to be X. And then I have my number of signs. 2, I have indicated it to be, from the question is 17. But I have already found my signs only. And my signs only is 9. Then I have my intersection to be 8. And then I have my X for math. But because the math is not only, I have to subtract the intersection from 8, as I have re-echoed today. I am not going to subtract 8 from 9 because I have already done it. It was 17 and I've done so. And so this is that. And what I'm left is my region 4. So I put it there. And this ends my Venn diagram. And this ends my Venn diagram. So I have satisfied the first demand, and so that is for I. If I go to II, that is where they said I should find math. And so my math, I've indicated that let those who study math be S. So whatever I'm going to find for S is going to be my mass. And so I'm going to put my II there. And so for my math, I'm going to have X minus 8, that's region 1. Plus region 2, plus region 3, plus region 4. As I earlier on did, it will be equal to the universal set. Now, once again, negative 8 plus 8 is a number and its identity, which always gives you 0. Therefore, we have X, and then 9 plus 3 is 12, equals 25. Then I make my S the subject. So I'm going to get my X equals to 25 minus 12. And then 25 minus 12 is going to give me 13. So it means that those who studied math, 13 students have done that. I've done that. Now, Then they are asked to find the probability of those who studied only one subject. The probability of those who studied only one subject. So the probability of those who studied only one subject is region 1 and region 3. Only one subject is region 1 and region 3. That is only one subject. So anytime they ask you only, don't forget that we have region 1 only and region 3 only. And so if you want the probability, it is region 1 and region 3. And region 1 is x minus 8. And then our region 3 is 9. And probability is always fraction. And the fraction is over the universal set. Over the universal set. And the universal set was 25. So over 25. So this is for one subject only, the probability. But we know that our x is 13. That is what we have just found. So if we put our 13 there, we have 13 minus 8 plus 9 out of 25. And so if you want to deal with the bracket first, then we have 13 minus 8, and that is 5. So we have 5 plus 9, that gives you 25 out of 25. And this is going to give me 14 out of 25. But you must always make sure that your fraction is in the lowest form. If not, you should try and reduce it. But because it is in the lowest form, we are going to maintain it like this. Then finally, let me deal with the last one. The set that deal with algebra. So I'm going to quickly go through one question quickly, and then I'm going to wrap up. I would like to finish it today because in the next meeting, I would like to deal with statistics, which is another important topic that you must expect in your final exams. So I am going to deal with it. So quickly put the last question for me. Let me deal with it. Said in a class of 60 students, the number of students who passed biology is just small than the number of those who passed chemistry, and that every student passed at least one of the two subjects, and a student passed both subjects. So you can also be given a question like this, where it is done in an algebra form. And so you should be able to know how to deal with it. So in a class of 60 students, the number of students who passed biology is just small than the number who passed chemistry. Now, we don't know those who passed chemistry, and we don't know those who passed biology. But we have been told that it doesn't matter the number of students who passed chemistry, those who passed biology are just small. So let us take those who studied chemistry to be X. So number of C. If our number of C is X, which we don't know, then we have been told that biology is just small. And just small simply means add 6 to the number of those who are studying chemistry. And so our number of biology is going to be X plus 6. And then our intersection, they have said, is 8. So number of B intersection C is 8. Then this is the information that they have given us. And so we put this information down. Now our number of U, they have given us to be, please, the question back, we have 60. So we have that. So quickly, I'm going to draw my Venn diagram. And so I'm going to put them there. I am wrapping up because my time is up. Bear with me. So my number of B is equals to X plus 6. And then my number of C is going to be X. So I put my number of B, X plus 6, my intersection is 8, my universal set is 60, and then my number of chemistry is X. But I've told you that because it is not only, they do not say only in the question, I must subtract 8, which is the region 2 from it. And so that is for my Venn diagram. So if I want to find my biology and the rest, then I'm going to have my I. I'm going to have my X plus 6 minus 8 plus 8. Plus X minus 8 is equal to 60. So I have that. Then once again, this and this will give me 0. This and this will give me 2x. And then if I have 6 minus 8, I'm going to get negative 2. And this is equal to 60. Then from here, I can make x the subject. So I have 2x equals to 60 plus 2. Therefore, my 2x is equals to, therefore my 2x is equals to 62. If I find x, I divide both sides by the coefficient of x, which is 2, Therefore, my x is 31. Don't forget that my S is those who studied, chemistry. So if I want biology, number of biology is x plus 6. Is x plus 6. But my x is 31. Therefore, my number of B becomes 31 plus 6, which is 37 in that case. So these are the 4 ways you can approach sets. I hope this lesson has been very helpful to you. We are grateful that we've been able to delve much into sets, and we are bringing it today. If you have any question, send it in the quorum question. The last time I have a question on social studies, and I've dealt with it. And so you can also bring your questions, and I'm going to send you the answer. Take note that you're in COVID-19 period. Protect yourself at all times, and stay home and stay blessed. Up next is English language. May God bless you and have a fruitful day. My name is Mr. Samson Anane. I was your mathematics facilitator, and I hope I've been helpful once again. May God bless you all.
Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.